Good evening. Thank you for coming to our presentation on a developmental perspective on allostatic load. I'm presenting tonight on behalf of my co-authors, Vanessa Volpe, Kathy Proper, Roger Mills-Coons, Ellie Brown, and Sarah Jaffe. Allostatic load refers to the accreting toll of repeated or chronic mobilizations of the body's typically adaptive stress response systems. Greater allostatic load, as indexed by biomarkers such as blood pressure and waist circumference, is associated with poorer physical and mental health outcomes. Research on allostatic load is focused on older adults, despite the fact that evidence suggests that stress begins to disrupt biological systems as early as preschool, and that allostatic load can be reliably measured in children 9 years and older. Given that early intervention yields greater benefits than later intervention, all else being equal, there's a compelling motivation to screen for stress or disadvantage-associated health conditions among children, adolescents, and young adults. Accurate screening requires addressing two pressing measurement questions. First, can a unidimensional model that is consistent with allostatic load theory be fit to a data set of biomarkers collected from individuals who are younger than those who have typically been included in studies of allostatic load? And second, if a unidimensional model does fit these biomarkers for these individuals, does that model display properties of measurement invariance across these age ranges? To address these questions, we used the NHANES, or National Health and Nutrition Examination Survey data set, because it's one of the few large publicly available data sets that includes biomarker data for children and adolescents. Our analytic sample included the 4,260 participants who fell into one of the youngest age groups as defined by the NHANES guidelines in the 2009-2010 survey cycle: 8 to 11 years old, 12 to 19 years old, and 20 to 39 years old. This table displays descriptives for and correlations among the biomarkers included in the data for the sample as a whole. The correlations indicate that the strength of the association between any two biomarkers varies substantially, but there are many robust intercorrelations among those biomarkers. This table presents the correlations by age group. Here we can observe substantial heterogeneity in the pattern of correlations across age group. Based on a series of exploratory factor models, all confirmatory models were specified as having a unidimensional factor structure consistent with allostatic load theory. Here we see the fit statistics for the initial confirmatory model, which includes all biomarkers, and the final model, which excluded albumin and pulse. The final model was an excellent fit to the data, and each of the measured variables loaded significantly on allostatic load, and each accounted for a significant portion of the variance in allostatic load. To test for measurement invariance, we estimated a series of multiple group models in which age was the grouping variable, and had three levels of corresponding to the three age groups in the analytic sample. A likelihood ratio test using the procedures outlined by Santor and Bentler was used to compare the fit for the configural model to that for the weak invariance model. This test yielded a significant result, which strongly suggests that the construct of allostatic load does not display the same factor structure across the three age groups. Post hoc analyses of the within age group correlation matrices suggested that there was a higher degree of interrelatedness or coherence among the measured variables for young adults than for children, and for children than adolescents, as indexed by the mean sum of the squared correlations among biomarkers within each age. In sum, our study indicated that, consistent with allostatic load theory and prior research, a unidimensional factor structure fit data on biomarkers in a nationally representative sample of children, adolescents, and young adults. However, this model did not display properties of measurement invariance across age groups. Indeed, the fact that weak factorial invariance could not be established indicates that the set of biomarkers that contribute to allostatic load for children is not the same set that contributes to allostatic load among adolescents and adults. This may be because the correlation matrix among biomarkers changes across these ages as our post hoc analyses clearly demonstrate. Future research should explore the question of invariance using narrower age bands, which could be used to identify inflection points in the construct of allostatic load, and may reveal that, within a sufficiently narrow range of ages, allostatic load displays not only weak factorial invariance, indicating that the same biomarkers meaningfully contribute to the construct across those ages, but strong factorial invariance as well. Establishing the latter form of invariance would allow researchers to interpret observed differences in allostatic load scores across ages within that band, without concern that some portion of those differences was attributable to artifact imposed by measurement variance. So again, I'd like to thank you for attending. I'd like to thank my co-authors, and I look forward to discussing these results with you during the chat session.